Hello, and welcome back on your mathematical journey. So we're going to keep going on our No More Fear of Factoring series. We're going to take a look once again at our trinomial algorithm. We're going to see how it works for polynomials where we have once again a quadratic of this form, right? ax squared plus bx plus c. But now we're going to look at the case where a is not equal to 1. So notice here, right, 3x squared plus 5x minus 12. The first thing I like to do is let's identify what a, b, and c are, right? In this case, a is going to be the number in front of our x squared term, which is going to be 3. B is going to be the number in front of our x term, which is just going to be 5. And then lastly, c is our what we call our constant term, right? Just the number without a variable, which is going to be minus 12. So, once again, we'll make use of this little quick chart, or however you want to present it, right? The first thing we'll write here is we'll write what is the quantity a times c. Well, 3 times negative 12 will give us negative 36. And then, right, we want the quantity b here, which is just 5. So, much like in the previous video, the goal at this point is we want to come up with two integers that multiply to negative 36, but add up to 5. Right, we'll notice here that if we have two numbers that multiply to a negative number, well, we need one of them to be positive and one of them to be negative. And then we notice here, right, that since we're adding them up to a positive number, right, we're going to need the positive number to be larger than the negative number in magnitude. So I'll give you a minute to think about what those two numbers would be. Right, so if you've thought about it, right, you've gone through your combinations, right, 12 times negative 3, well, 12 minus 3 is 9. That's not quite small enough here, so if you need to make your difference, in this case, smaller, right, you want to move the factors closer together. So ultimately, the pair we're looking for here, right, again, in no particular order, is going to be 9 and negative 4, right? 9 times negative 4 is negative 36, and 9 minus 4 is 5. So, unfortunately, in this case, we're not quite done, right? In the previous video, when a was equal to 1, we could just essentially go ahead and plug these integers in to sort of our binomial factors, and we were on our way. So when a is not 1, what I'm going to do next is I'm going to do the following. I'm going to write out a polynomial where I'm essentially going to expand this term here, 5x, into a combination of this term here, 9x, plus this term here, minus 4x. So the whole thing written out, right, we'll keep the 3x squared the same. We'll keep the minus 12 the same. But instead of this being plus 5x, right, I'm going to make it plus 9x minus 4x. Now, this might look like a less resolved version of this one, but at this point what we're going to actually do is we're going to take advantage of the grouping factoring mechanism that we went over in a previous video. So, right, remember in that case we were considering grouping when we had 4 terms. Well, in this case we sort of have 4 terms, so we'll go ahead and apply it. Right, so the question is, what is the greatest common factor of 3x squared and 9x? Right, well, 3 and 9 are both divisible by 3, and x squared and x both have a factor of x in them. So we can go ahead and say that 3x squared plus 9x, right, well, 3x squared divided by 3x is just x, and then 9x divided by 3x will be just 3. So that's the group factoring, right, by the greatest common factor of the first two terms. Now let's take a look at the second two terms, right? What is the greatest common factor here? Well, right, generally speaking, right, there's no variable in both terms, so it's just going to be a number, right? And the greatest common factor of negative 4 and negative 12, this is a bit subjective, is that you could technically say it's 4, and that's not incorrect. But for the purposes of this factoring, I'm actually going to go ahead and factor out a negative 4 out of both terms. And we'll sort of quickly see why I did that, right? Let's see. Negative 4x divided by negative 4, right? The negatives will cancel, so I'll just be left with x. And then negative 12 divided by negative 4 is just going to be positive 3. So, if it's not clear by now the reason I chose the negative 4 instead of the plus 4 is my goal is to make what's inside the parentheses here match up directly with what's inside the parentheses here. Right, so had we done this as plus 4, we would have gotten minus x minus 3. You could have then gone ahead and factored out a negative 1 and then combined the plus 4 times negative 1 to get back to this minus 4. But our end goal is to perform that grouping factoring using GCFs so that what we get inside here matches up identically. The last step we can do, right, is we can say that since this is 3x times some quantity minus 4 times some quantity, we can think about, in some sense, factoring out this quantity, right? X plus 3 is sort of our greatest common factor now of this term and this term. And when we factor out x plus 3 out of each of those terms individually, right? 3x times x plus 3 divided by x plus 3, well, those will sort of cancel out, so we'll just be left with 3x. And then, additionally, right, minus 4 times x plus 3 divided by x plus 3 is just going to be minus 4. So, if we've done everything correctly, and we can always check via FOIL, when we FOIL this out, we should get back to here. So let's take a peek, right? X times 3x, that gets us our 3x squared, right? X times negative 4 is minus 4x plus, right, 3 times 3x, so plus 9x. So we have a minus 4x plus 9x, which gets us back to our plus 5x. And lastly, 3 times negative 4 is in fact negative 12. So a little extra step, we do have to perform that grouping, right, with GCFs at this stage. But relatively speaking, straightforward once you get the hang of it. Anyway, I know that one's a little bit more complicated, so feel free to ask if you have any questions, comments, or concerns. Otherwise, happy mathing, and have a good day.